Hello and welcome. In this video, I'll be presenting my project, a phishing email detector. This project was developed as a part of my academic coursework and covers the full pipeline of a real machine learning system. From understanding the problem to processing data to training and evaluating models, and finally deploying a live web application that anyone in the world can access and use right now. My name is Umnia, and throughout this video I will walk you throughout how the system works, what decisions were made during development, and what results we achieved, and I will demonstrate the live system with multiple real test cases. I will not be going throughout the code line by line. Instead, I want you to understand the solution, the thinking behind it, and see it working in action. Let's begin. Before we look at the solution, let's understand the problem we are solving. Phishing is a type of cyber attack where criminals send fraudulent emails pretending to be a trusted organization, your bank, your university, a delivery company, or even a government institution. The goal is to trick you into clicking malicious link, providing your password, credit card details, or other sensitive personal information. Well, what makes phishing so dangerous is that it doesn't exploit a technical vulnerability in a computer system. It exploits human psychology. It uses fear, urgency, and trust. Well, a phishing email might tell you that your bank account has been suspended and you must verify your identity within 24 hours or lose access permanently. Most people panic and click without thinking. The scale of the problem is enormous. Phishing is constantly ranked as the #1 initial attack vector in data breaches worldwide. Billions of phishing emails are sent every single day. No human team can manually review that volume of emails. Automation is not optional, it is essential. This is exactly the problem our system addresses. We want a machine that can read an email, understand its content and structure, and make an instant, accurate decision. Is this phishing or is it legitimate? Our solution is a supervised machine learning system built on top of natural language processing techniques, NLP. Let me explain how it works at a high level before we go into the details. So the system works in 3 main stages. The first stage is understanding the email. When an email arrives, the system reads the raw text and cleans it up. It removes irrelevant noise like HTML formatting, strips, punctuation, and numbers, converts everything to lowercase, and then breaks the text into individual words. It removes very common words that carry no meaning. Words like the, is, ought, which, because they appear in every email regardless of whether it's phishing or not. Finally, it reduces each word to its base form. So verifying, verified, and verification all become verify. This gives the system a clean, normalized representation of the email's content. The second stage is feature extraction. The system converts the clean text into numbers because machine learning models work with the numbers, not words. It also extracts specific signals known to be associated with phishing. The process of urgency language, the length of the email, and the density of exclamation marks. All of these features are combined into a single numerical representation of each email. The third stage is the classification. A trained machine learning model takes that numerical representation and outputs a prediction, phishing or legitimate, along with a probability score telling us how confident the model is in its decision. That's the full pipeline: clean, extract, classify. Let's now go through each part in the more detail. So every machine learning system starts with data. Our model was trained on a dataset of 10,000 labeled email samples. Each email in the dataset has been labeled by a human as either phishing or legitimate, which is what allows us to train supervised classifier. The dataset contains 6,000 phishing emails and 4,000 legitimate emails. A 60-40 split, as you can see. This is considered a mild class imbalance. It means phishing emails are slightly over present it, which is actually realistic. In the real world, spam and phishing filters see more malicious emails than legitimate ones. We handled this imbalance during training by telling the models to pay equal attention to both classes. Well, each email in the dataset also carries metadata, the type of phishing attack, for example, credential harvesting, financial scam, or authority impersonation, a severity level, and a confidence score. The dataset has 0 missing values across all columns, which means we start from a very clean foundation. Now I want to be transparent about one important characteristic of this dataset. It is synthetic, meaning the emails were algorithmically generated rather than collected from real inboxes. This was a practical choice for a university project, but it does have implications for real-world performance, which I will discuss later in the limitations section. Now let's talk about features in more detail, because the quality of your features determines the quality of your model. Our feature set has 2 components. The first and most important is TF-IDF, which stands for Term Frequency Inverse Document Frequency. This is a standard technique in text classification. Here's the intuition behind it. If a word appears frequently in a specific email but rarely across the entire dataset, it's probably a meaningful and distinctive word for that email. If a word appears everywhere in every email, it carries no discriminative value, which means it doesn't really have that much value. We extracted up to 5,000 of the most informative words and 2-word phrases from the training data. Bigrams, 2-word combinations, are particularly valuable here because phrases like verify account, credit card, security alert, or click here carry much stronger phishing signals than any single word alone. The second component is our 3-handcrafted features. The urgency flag is a binary signal. It equals 1 if the email contains any of our urgency keywords. Urgent, verify, suspended, action required, security alert, or unauthorized. The character count captures the overall length of the email, and the exclamation count captures punctuation density. Phishing emails tend to use exclamation marks aggressively to create emotional pressure. All 5,003 features were combined into a signal matrix and fed into each classifier. The train and test sets were split 80-20 with stratification to ensure both sets maintained the same class balance. We trained and compared 3 different machine learning models to find the best performer for our task. The first model is Logistic Regression. Despite its simple name, Logistic Regression is a powerful linear classifier that works extremely well on high-dimensional sparse text like TF-IDF matrices. It is fast, interpretable, and produces well-calibrated probability estimates. Meaning, when it says an email is 90% likely to be phishing, it really is phishing about 90% of the time. The second model is Random Forest. This is an ensemble method that builds hundreds of decision trees on different subsets of the data and combines their votes. It is more complex and slower to train, but can capture nonlinear patterns that logistic regression might miss. The third model is multinomial naive bayes. This is classic probabilistic classifier specifically designed for text data. It is extremely fast and often surprisingly competitive despite its simplicity. Looking at this bar chart, you can see how the 3 models compare on F1 score, our primary evaluation metric. F1 score here is the right metric because it balances precision and recall. Precision tells us of all the emails we flagged as phishing, how many actually were. Recall tells us of all the actual phishing emails, how many did we catch? F1 is the harmonic mean of both. A high F1 means the model is both accurate and comprehensive. Logistic regression came out on top, followed closely by random forest, with naive by slightly behind. All three models performed very well, which validates our feature. Now I want to honestly discuss the limitations of this system, because understanding what a model cannot do is just as important as understanding what it can do. The main limitation is our training data. Because it was synthetically generated, the model has only learned from a narrow style of writing. Real-world phishing emails are far more varied, creative, and sophisticated than what the model was trained on. And real legitimate emails, especially formal professional or academic ones, are more complex than the simple casual messages in the training set. This can cause misclassifications on real emails, as we saw in some of our tests. A production grade system would be trained on millions of real emails from datasets like the Inron Corpus or Spam Assassin. It would also incorporate URL analysis, checking whether links in emails point to suspicious domains, and sender authentication signals. And ideally, it would use a transformer-based model like BERT, B-E-R-T, which has a much deeper understanding of language context and meaning. These are clear and achievable next steps that would take this from a university project to a production-ready system. Now, the most important part, let me show you the system working live. This is the deployed web interface running permanently on Hugging Face spaces. I'm going to test it with several different emails covering a wide range of scenarios. To wrap it up, in this video I demonstrated a complete end-to-end phishing email detection system. We converted the problem of phishing and why automated detection matters. We walked through the full machine learning pipeline, from data processing to feature engineering to model training and evaluation. And we saw the system working live across different email test cases, covering credential harvesting, financial scams, authority impersonation, cyber phishing, and legitimate emails. Well, the live system is permanently accessible at the following link. Feel free to test it yourself. The full project code is available on GitHub at the link shown on screen. And thank you very much for watching.